In GCSE, you were shown how to find the exact values of some of the trigonometric ratios for the angles of 30 degrees, 45 degrees and 60 degrees. At A level, you need to know those numbers off the top of your head, and you certainly need to be able to prove mathematically why they have those values. Okay. So, in terms of showing where they come from, the 45 degree angles, we know we have a right angle triangle. If that's 45 degrees, then we know that would have to be 45 degrees as well. And therefore, it's going to be an isosceles triangle. So if we label up these other sides with, well, let's just call them 1 for now. I know they're going to be the same. Then that would have to be root 2. Just from a quick bit of Pythagoras, 1 squared plus 1 squared square rooted. And just from that basic information here, we can now write down what sine 45 is, what cos 45 is, and what tan 45 is. So, sine we know is opposite of hypotenuse, so 1 over root 2. Which we could rationalise if we want to, and write that as root 2 over 2. Cos 45? Well, we know that cos is the adjacent divided by the hypotenuse. So that's 1. The adjacent is 1, the hypotenuse is root 2. So 1 over root 2, which is root 2 over 2 again, when you rationalise it. And finally, tan 45, we know tan is the opposite divided by the adjacent, so 1 divided by 1, which is just 1. So there we go. Those are the exact values of the trigonometric ratios for 45 degrees. You need to know them, so if your teacher just fires at you, what's tan 45, you need to be able to say it's 1. And you need to be able to show why it's 1 as well. So there we go. What about the other ones? What about 30 degrees and 60 degrees? Well, what you do for that, you draw an equilateral triangle. So I know that's 60, I know that's 60, I know that's 60. I know this side is the same as this side, is the same as this side. And what I'm going to do is I'm going to split it in two, so that I can have a right angle triangle. The other good thing about doing this is that's going to mean this angle here is 30 now, because the whole thing was 60. In terms of filling up the sides, I'm going to call this side 2, which means that this would be 2, and the whole thing on the bottom would be 2. So if this whole length on the bottom is 2, but I've split it in half, just this little bit here would be 1. Quick bit of Pythagoras to work out the perpendicular height here. 2 squared is 4, subtract 1 squared, so I get root 3 when I've square rooted. And now same idea as what we did over here, we can now work out all of the trigonometric ratios. So for example, if I want sine 30, right, there's 30. Sine is the opposite divided by the hypotenuse. What about if I wanted tan 60? Well, here's 60, and I know tan is the opposite divided by the adjacent. So root 3 divided by 1 is root 3. If I wanted cos 60, go to 60. Cos is the adjacent divided by the hypotenuse. There we go. Anyway, I'm not going to do them all. You need to be able to do these yourselves. Okay?